Hello, everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch. I'm a developer advocate at AWS. And this is the show for everyone wanting to build or planning to build a SaaS product. In this show, we dive deep into SaaS-specific topics so you can learn more about just that, building SaaS on AWS. I bring on SaaS experts to talk about specific topics every other week. And this week is, of course, no different. This week, I'm joined by Bapi and Ranjit. Welcome to the show, fellas.
Thank you. Thank you, Gunnar. Hello, everyone. I'm Bapi. I'm a partner solution architect working in SaaS Factory, building SaaS products and helping customers and partners delivering SaaS products.
Hey everyone, my
Bapi,
name is Ranjit.
welcome. Yeah, go ahead, Ranjit.
Hey everyone, hey Gunnar. My name is Ranjit Raman. I'm a senior solutions architect with AWS SaaS Factory team, and I'm happy to be back on the show.
Yeah, is it your third time now, Ranjit?
Yeah, this is actually my third time. Yeah, you're right.
Yeah, great having you back. So welcome both of you. And to the viewers, if you haven't watched the show before, we want to make this interactive. So if you have questions, if you have comments, just post them in the chat and we'll try to answer those SaaS questions throughout the show. But we'll focus on a specific topic for each show. And of course, we'll do that in this show as well. And this time, we're going to talk about enhancing Amazon EKS SaaS solutions with the AWS CDK. So I think we perhaps need to have a bit of a backstory to this. Ranjit, maybe.
Yeah, absolutely. So we have looked into the Amazon EKS SaaS reference architecture. We have done deep dives on it. We have done it a couple of times. First was a deep dive, and then more recently we did a session on service mesh, but we also looked into some aspects of the EKS SaaS reference architecture in that show. So the thing is, we launched the solution sometime early last year. I believe it was in March. So the EKS SaaS reference architecture, just for folks who are new to it, it is an end-to-end example of a multi-tenant SaaS solution that runs on Amazon Elastic Kubernetes Service or Amazon EKS. And we launched it early last year. And since then, we have received a lot of feedback, a lot of feature requests or call for enhancements. And there were also things that we wanted to add at that point, which we couldn't get it in before the launch. So what we thought was, maybe we need to come up with a vNext sort of a version, like a next version of the reference architecture, and that's exactly where we are now. So we have a new branch as part of the GitHub repo. It's called vNext, with a set of enhancements that we have worked on over the last 1 year or so. I think it would be better if we bring up a slide where we can show the conceptual view of the stack. Okay, perfect. All right, thank you. So for folks who are not familiar with the solution, so this is this is a conceptual view of the EKS SaaS reference architecture. So you can see that there is a Amazon EKS cluster down below, and that is a single cluster, and we are going to host multiple tenants or co-locate multiple tenants or customers within that single cluster. And you can see that there are some shared services, right? So we have looked into this before on previous shows. The shared services are, they have a cross-cutting concern. They're used for tenant onboarding or things like tenant provisioning. So there is a registration service, there is a user management service that establishes the identity and the authentication requirement aspects of things. And there's also a tenant management microservice that provisions like tenant specific resources and all that. So there are some shared services. There are also application services. For example, there's a product service and an order service that we deploy on a per tenant basis, right? And we use a construct called a namespace, which is a Kubernetes construct. We follow a namespace per tenant model. But again, like we have said before, that is not the only way to do it. There are other patterns as well, but we fill a namespace per tenant model a great use case for anyone building a SaaS application. But again, it's not the only way to do it. And on the top, and I'll start from top left. There is a landing or a sign up application. You can think, so this is a marketing page that the SaaS provider might have, where someone can go in and sign up for the solution, right? So it's a website, and then once you have signed up for the solution and the SaaS provider has provisioned all your resources, you'll be provided with an endpoint or URL for your SaaS application. So that's what we see in the middle. So that's the tenant application, the SaaS application that the tenant would use to log in. And then finally, further towards the top right, there is admin application, which is a SaaS provider's admin console used by the administrator or people within the SaaS providers, like whoever has the role of an admin. They can use that application to have a view of all the tenants that's using the application, and so just from an administration standpoint, right? So that's the conceptual view of the stack. So we wanted to make sure we put this here, even though we have looked at this a couple of times. This is to sort of set the stage about what we are going to actually talk about today.
Yeah, and as you mentioned, we've had a deep dive episode of it, and our friend Bill has posted a link to that episode in the chat. So check that out, but wait until this episode is over, of course. And so you talked about improvements to this stack. So what are some of the improvements you made to this SaaS reference architecture?
Yeah, absolutely. So, like I said, we went through. It's been a little bit more than a year since we launched the solution, and we have received feedbacks through GitHub discussions, or we have presented this to several customers and partners, and we did receive several feedbacks and call for enhancements and feature requests, and we put together a list. And what you're looking at is some of the top 4 or 5, like 5 items, but there are more that we didn't add here, but these were some of the top items. And one of the first things that we wanted to do was use Amazon CDK, which stands for Cloud Development Kit, which is an open source infrastructure as a code framework that lets you deploy cloud resources in a more automated and repeatable fashion, using a programming language of your choice, right? So it supports TypeScript and Java, and there are other programming languages as well it supports. So we wanted to use CDK because in the current version, we are using CloudFormation, which is great, but there are a lot of scripting involved. Like, for example, to provision an EKS cluster, we use a script. We use EKS Scuttle, which is a command line interface, and it's part of a script. And then there are several sort of add-ons that we add to the EKS cluster. They're all embedded within scripts, like the Nginx ingress controller and all that are part of scripts. So we wanted to move away from that and make it more, use something like a CDK, something that's more manageable. So that was one of the first things that we wanted to do, and we use that for the baseline, for provisioning baseline infrastructure, and also during tenant onboarding, we have used CDK, and we'll get into why the specifics of why we actually did that for tenant onboarding in a little bit. And the second item was, a custom domain is no longer required because the current version of the EKS reference architecture, or the SaaS reference architecture, requires you to bring in your own domain. So which was a little bit of a not a challenge, like most people can bring their own domain, but it was still sort of a barrier to entry, and we wanted to lower that a little bit. So if you have a domain, you can still use it, but it's not required anymore. If you don't have it, you'll still be able to run the solution. And the third item was automated update process, and this was something that we received, as a feedback from customers. I believe there was a GitHub discussion as well on this, and this was also something that we wanted to do as part of the first launch, but we couldn't get it in. So what this essentially is like, for example, in the current version, we tell you how to deploy the microservices across all the tenants, right? But there is no good update story. For example, if you want to go and update a microservice, you'll have to do that manually, right? But the idea was to make it automated. So we have restructured how we create, so we have like separate source code repositories for each of the microservices, and then we have a CI/CD process. So anytime you make an update, it'll trigger the pipeline. The CI/CD pipeline will pick it up, and then it would deploy the change across all the tenants. Something that we have found to be very useful. You know, and then moving on, the fourth point is we have added API Gateway, which is an API management solution from AWS, which lets you create and publish, manage, and monitor APIs in your solution. So we have added that as a capability, as an ability where you can manage your APIs, but also use that for use cases like tiering and throttling. And we'll get into how we actually do that. And finally, the final point is CubeCost integration, and this is probably one of the most requested features, because as you can imagine, if you're building a SaaS application, cost attribution is usually something that you have to think about, right? Especially if you're using shared resources or shared clusters where you host multiple tenants, you want to know how each tenant is using your cluster or using the resources. So what we have done is we have integrated with CubeCost, which is an open source solution. There is also a paid version if you need support. So we have added that feature. It's optional. If you want to integrate it, you can add it. If you don't want, that's fine too. But we wanted to provide that ability where you're able to attribute cost per tenant, and the whole cost tracking methodology. and yeah. So these are some of the top enhancements. There are others which is not here, but the idea was to enhance the application, to enhance the solution based on some of the feedback that we received in the field from customers and from other users, internal users. So
that's great to see and hear that it's based on feedback from customers and users, of course. And if you watched this show before, any of my other shows, you know what I think about PowerPoint slides in these Twitch shows, but we kind of had to have a slide to be able to show all of these enhancement here. But I promise you, we'll get to code, we'll get to demos later on in the session, so no worries. All right, so maybe should we start looking into some of these enhancements then?
Yeah, sure. Thank you, Ranjit. Yes, these are really nice to have enhancements, and we are always listening to the customers and the community, so that we can bring in what's required for you and what do you need. But making those changes, one thing we always kept in mind so that you can anchor to your previous experience. And that's what motivated our architectural overview. So what's coming in vNext? So this is the vNext architecture. As usual, we have the three static sites, the client application, the e-commerce application that we have. It's a dummy application, but works as an e-commerce SaaS application. We also have the self-serving registration of sign-up page, and we have the SaaS administration panel. So these are the three static sites built using HTML, JavaScript, CSS, and they are used by the tenants and the SaaS administrators that we have in our systems. So the tenants usually sign up themselves into the landing page of the registration site, and they always interact with the SaaS application itself. Whereas SaaS admin can actually administer tenants, maybe onboard a new tenants or activate, deactivate tenant account using the admin panel. So these three static sites are served from CloudFront, and that CloudFront distributions are backed by Amazon S3, where we store our static assets, like the HTML files, images, CSS, and JavaScript files. So these sites, especially the SaaS client application and the SaaS admin panel, they make use of Amazon Cognito for authentication. So once authenticated, we receive the authorization token, and we make use of that in the later stages of the calls. So once we have the authentication token, all of the requests are now going through Amazon API Gateway, as Ranjit was mentioning before. So this is a new component that we have added into this architecture, the Amazon API Gateway. All of the calls that are going to our system are always going through the Amazon API Gateway. We are using Lambda Authorizer, which was previously known as Custom Authorizer for Amazon API Gateway. The reason for doing that is not only we get the goodness of decrypting the incoming JSON Web Token, but we can also use something called usage plan so that we can implement tiering and throttling of incoming request per tenant. On the right-hand side, we have the Amazon EKS cluster that Ranjit was showing you previously. This is the exact same view, just flipped vertically. So on the top part of the diagram, we have the application services. These are tenant-specific services, and we only have two microservices now to demo, which is the product and order microservices. And they are available in each of the tenant's own namespace. I would like to enforce the notion again that each tenant has their own namespace, and that's the design guideline we went with. As Ranjit was saying, this is not the only way of doing things, but this is what we choose to do. And on the bottom section of the diagram, we have the shared services, again, very similar to the previous slide. We have registration, user, and tenant management services, and they're all deployed within the EKS clusters. All the requests are going into the EKS cluster through a private network load balancer, and they are being routed using Nginx ingress controller within the EKS cluster. So it is deployed within the EKS cluster, and it's handling all of the requests incoming through the network load balancer. So however, if you look at this diagram, we have the publicly accessible part on the left-hand side up until API Gateway, and we have the right-hand side, which is your private protected resources, including the network load balancer and Amazon EKS cluster. We are using something called VPC link to integrate these two. So all of the requests coming from API Gateway goes through VPC link to your private network load balancer. And then it reaches the Nginx and the ingress controller deployed within the Amazon EKS. So this is the architecture from a very, very high level. It is somewhat very, very similar to the previous version. The only new component that we can see is the API Gateway integration with private load balancer with VPC link. And as Ranjit was saying, there are automation built into it, like tenant onboarding, upgrading service. So to achieve that, we had to make use of AWS code pipeline and AWS code build heavily. We will jump into that pretty soon, and we will see some codes and even some live demos of that happening. But yes, this is the architectural overview of a vNext SaaS application built on Amazon EKS.
And comparing that to the previous version, the main difference we can see here is that Amazon API Gateway is added, right?
Yes, true.
Yeah, and we're also bringing in, so the architecture is very similar. We are obviously adding API Gateway, and we already use code pipeline and code build. They are not new, so it's part of the current portion as well. But we use that for an install. Like we don't use that for the update process, which is a big enhancement we are doing in the vNext version.
Right. So a question in the chat, if each tenant has their own databases, just like they have namespaces. So how are they being how are they being separated?
Well, so in this solution, we are using DynamoDB, and it's a shared database, shared construct. But really, I mean, if there is a need to have a tenant specific database, absolutely. Like we the requirement of your application, and there could be tenants. For example, you could have a tenant that's in a premium tier that you want complete isolation and you want to provision their own database or databases, right? So that's totally fine. But there could be tenants that may be in a lower tier that you may want to share databases or shared tables with appropriate isolation, that's totally fine too. We have seen both the models, but in this solution, we are using shared databases or shared database where we are co-locating, or it just shares uh, tenant records within the same database. But you can absolutely have a separate database per tenant.
Right, and I think we talk more about that in that SaaS EKS reference architecture episode as well. So please go back and watch that episode for more details on how tenants are separated in the reference architecture.
Absolutely. Yes. So although we are using shared databases, we are actually showing two ways of achieving isolation, the siloed model and pooled model. So the assumption in the case SaaS reference architecture is product data can live in a shared table that is shared by all of the tenants, whereas ordered data we are storing in separate tables per tenant. So these are just to show how we can achieve isolation with which is enforced by IAM policies. But this is just an example, and anyone can take this example and implement their own business case.
All right, so should we start diving into the technical bits of it?
Thank you. Yes, so just a bit of housekeeping, how to get started with vNext. This is not merged into the main branch yet, so we'll have to check out the vNext branch. So step 0 is clone the repository, check out the vNext branch. And as usual, it's written using CDK, which is a TypeScript. So we have to do npm install before doing anything else. So step 1, ways of installing it. 1, we do not need any custom domain anymore. It's no longer required, as Ranjit said. All we have to do is type npm run deploy and pass in the email address of the SaaS administrator. That's the only required value that we need to run the script. And it will create many things. I will go through them in detail later on, but this is the only required value that we need. Optionally, if one wants to use their own custom domain, we can also do that. So you have to type npm run deploy with email, the domain, and the hosted zone ID where this public domain is, the public hosted zone ID where the domain is added. As Ranjit was also saying, the CubeCost integration is also built into there. So after typing all of the parameters, either email only or custom domain and hosted zone ID, if you have a CubeCost token, it can be either a paid version or a free version for the community. All you have to do is just pass in the parameter CubeCost token equals to token, and it will actually deploy the CubeCost workload in your EKS cluster, and it will also link your dashboard to the actual CubeCost data. Yes, so with that brief overview, we can definitely jump into the code section and have an overview of how the code is structured.
I think it would be good, to start from what happens when we do an npm install, right? So where does that take us?
Yes.
Like, if you can start from there.
Yes. So when we run npm install, the first file that actually runs is the apt.ts, and here we are collecting all of the information that are passed in. After collecting this information, we're creating a bunch of stacks. So namely, first one is the EKS cluster stack. I will go into that in a minute. So that basically provisions all of the EKS cluster and associated permissions and node groups. The next, we deploy the API stack, which is responsible for handling the API gateway deployment and integration with the network load balancer. Then we deploy another stack called static site stacks. Remember, we have 3 static sites, namely the SaaS application itself, the SaaS admin panel, and the self-serve landing zone or the sign-up page. So these 3 sites are deployed using this static site stack. Not only the sites are deployed, but also the CI/CD pipeline, everything is established using and under this stack. We also have common resources like metadata and tenant-specific information or the application-specific information that are deployed under this common resources stack. And after that, we deploy something called service stack, which is responsible for deploying and setting up the CI/CD pipeline both for tenant-specific services as well as the common services like registration, user management, and tenant management. If we can jump into the EKS cluster and see how this is organized. So what EKS cluster does, it definitely creates VPC and it looks for whether it needs to use a custom domain. It also creates the security groups needed for the control panel, control plane, and the security group for the node groups. Then it finally goes on creating the cluster, and then it also creates the VPC CNI plugin that is required for our networking restrictions and maintaining the network connectivity between the different pods. We also set up node role, launch templates, and finally we launched the node group, which is auto-scaled node group. And then we create a kubectl role that is used by our CI/CD pipeline in both code build and code pipeline. And finally, we install the Nginx chart, the Nginx image controller as a Helm chart. And that is also deployed as a part of this onboard, as a part of this EKS cluster deployment process. And additionally, if we have provided a CubeCost token, we also install the CubeCost again in a very similar manner using Helm chart and other deployment mechanism available in Kubernetes. So that is the high-level overview of what happens when we actually deploy things using npm install.
And comparing that to the first version or the previous version, it seems a lot easier to get started using this now, just with the npm install command, basically.
Mm-hmm.
That's right. That's right. Yeah, because in the current version, the previous version, we have to run through a set of deploy scripts. First, we, set up toolings. We set up, we do a bunch of, we obviously start with by creating an EKS cluster. Then we call another script. Then there is a third script, right, to do add-ons. Now all that is gone, and all you need to do is an npm install, and it comes right here, and then just executes everything that you see on the screen.
That's great. All right, if you just joined us, this is Building SaaS on AWS. I'm Gunnar, I'm joined by Bapi and Ranjit. Today we're looking at enhancements of the SaaS EKS reference architecture for the vNext version. And right now, Bapi has walked us through what happens when you install it. We're already 28 minutes into the show, so let's continue, Bapi.
All right, thank you. So I think at this point, it is a good time to show some demo. But before doing the demo, I'd like to show once we run npm install, what actually happens behind the scene and how it is different from the previous version and where do the flexibility comes in. So if I can just share my AWS console with you. Right. So after we run npm deploy and we go to code commit, which is the repository. So
let's zoom in a couple of steps, Bapi, just to make sure people can see it.
Yes, thank you. I hope the level is all right now.
I think that's good.
That's good.
Thank you. So yes, once the npm install scripts and npm deploy script finishes running, we get this repositories created automatically for us without doing anything. So these repositories, for example, the admin site, the application site, and the landing site are the three repositories for the three separate static sites available. So the way it gives a user more flexibility is if you make any changes into this repository. For example, if I go into landing site, all of the codes available here are landing site specific. So if we make any changes into that landing site repository, the CI/CD pipeline is set up so that the landing site changes are deployed to the landing site hosted to the landing site distribution, the CloudFront distribution. And so previously it was somewhat difficult to do because all of the codes were tied up together. now we get this nice separation just by running npm deploy. Very similarly, we have all of the services here available as well. So product service and the order service are the tenant specific service in our EKS SaaS reference architecture example. So if we make any changes to any of these services, all of the changes are packaged up into the Docker container and then pushed into the container registry and then deployed the latest version into all of the tenant namespaces. But if we make any changes to the common services here, like user management and tenant management, these are only deployed to the common service area. So by convention, we are actually deploying common services into the default namespace. But that's not a hard-coded rule. Anyone, if you have any need, you can always change that default namespace as well. Yeah, so this is the flexibility. This is where the flexibility comes from, and this is the only tuning knobs, if I can say that, you have. So if we make changes to the code and the changes are immediately available, not immediately, after a build time and deployment time, they are available.
So this, what you're looking at is a big improvement from what we have in the current version, because in the current version there's only one entry, so there's only one repository here, right? When you go to the screen, you would just see a single repository, and all the services are organized as folders within that single repository, right? So I mean, there are ways that you could use a mono repo concept and then trigger builds and all that. Others are separate. There are a lot of people working on that aspect, but we still wanted to follow the microservices methodology, and creating a repository per service makes update and deployment a whole lot easier versus having just a single repository. So that's why we did this. What Bapi is showing.
And I would imagine using this reference architecture to then perhaps start creating your own SaaS solution is probably easier when you already have that separation of the different repositories.
Exactly. Absolutely. Yep.
So I think the users have waited long enough to see a live demo of this VNext. Luckily, we have it deployed, and I would like to bring that up into the screen. So this is the landing page or the self-serve sign-up site or the registration site, and this is exactly same as the previous version. No change has been made here, except if you look at the URL, you no longer need a custom domain. So this is a CloudFront provided domain, and we are using that. Again, it enforces the fact that you do not need a custom domain anymore. That is an optional feature. And so this actually makes it a great candidate when you are trying it out in your personal laptop or in any workshop where you do not want to bring your custom domain. So what we will do is, before jumping into the administration panel and showing you the features, I would like to start onboarding a new tenant, because this takes a while to provision the infrastructure needed and set up all of the entries that are required to onboard a tenant. So I'll just start by doing that. So I will give the tenant a name, Twitch tenant. Email, I'll use my email in case I need to do that. And the company name, maybe Twitch TV. So one thing to note, that your URL is automatically generated underneath. And because we're not using a custom domain, this understands that it has to be a CloudFront domain, and it auto-generates what your application will be hosted at. And we have to select a tier. I'll select the basic tier for now, and we'll start creating the tenant. So yes, successfully provisioned your tenant. That actually means that your request has been accepted successfully, and things are working behind the scene. And I will receive an email shortly when the tenant onboarding is completed. While we wait for that, we can actually have a look at the administration panel for the new SaaS admin panel in VNext. So it looks exactly same. except a new button that says CubeCost. We'll come to that later on, later in our presentation. But we'll have a look at the dashboard first. So the SaaS admin panel has a dashboard with few data that are being displayed. If you are familiar with the previous version, I think that displays a randomly generated data which has no correlation with the actual tenants in the system because it did not have any integration with usages and metrics that are being done or being consumed by the tenants in the system. However, when deploying this vNext version, if we are using a CubeCost token, this data is a real data that is coming from the CubeCost behind the scene. So if I hover on anything, it says tenant one, CPU usage in last 15 days is $13.94, and I believe it's in US dollars. And the memory cost on last 15 days is 93 cents. And these are all real data generated by CubeCost, and we're fetching it and displaying it into the dashboard. This is just an example that how CubeCost API data can be used to display a custom chart in the dashboard of the SaaS admin panel. Yeah, and the admin panel works exactly as before. So if we go into the tenant section, we can see the list of tenants when it loads. Sorry, I must have logged out due to timeout. I'll just log in quickly.
That's kind of mandatory during a live demo, so that's
yes,
fine.
and this is too.
So what happened was, so you saw that Buppy was, added a new tenant, right? And when he clicked on the create button or submit button, so it calls the shared services. So remember, we were talking about the shared services in the cluster, the registration, the user management, tenant management. So what's happening behind the scenes right now for that new tenant is we are creating a cognitive user pool, right? So we are establishing identity and we are creating all the tenant specific resources. And it's getting prepared, it's getting ready, and I think it should be ready anytime soon, right, Bobby?
Yes, definitely. So we'll just give it a few more minutes maybe, and we'll look at other features, like for example, the tenants that we have onboarded previously. We have tenant 1, 2, 3, and 4. We can also list users. Yeah, that's basically it, a very basic admin panel and a dashboard. And as I was mentioning, the CubeCost integration, we can actually show how the CubeCost works. So this is a link to the actual CubeCost dashboard. If we click here, it will open in a new tab. It will display the cluster that we have. And if we select the appropriate cluster, by the way, CubeCost in the free version actually supports one cluster only for one email address. So that's why we only have one cluster listed here. And by default, it will give us a lot of insights like what the monthly saving could be, what the monthly cost looks like, what is the cost efficiency score or percentage for us, where are the costs allocated, and Kubernetes assets that are tagged for cost, cluster efficiency, a lot of metrics. And we can also create custom reports in the report section. We can have a look at the assets that we have. We can also look at the cost allocation reports. So these are very insightful, and they come without any customization or custom effort. This is CubeCost as is. That's what I'm trying to say.
I think we can actually come back to the CubeCost aspect, but since the tenant is being onboarded, I think it would be good if we can show people here, like if you can go to code build, because the registration service kicks off a code build process, right? So if you can open code build, Buppy, and just show if the tenant that you just onboarded, like what happened with that.
Right. So as soon as we onboarded a new tenant, and we go to the code build service, we go to build projects, and there should be a service called tenant onboarding project. If we go to the build history, it completed just now, and the duration was 4 minutes and 45 seconds. We can see the logs that it actually onboarded a tenant. And the one thing I wanted to show you here, although this is a code build project, even the tenant onboarding itself is using a CDK project. The project is also hosted in the repository so that you can make changes and the new tenant onboarding experience will change. But I would like to show you the CloudFormation stack created by this CDK script. So if we remember, the tenant's ID was Twitch TV, and this is the stack for that particular tenant. And it created a few resources and all of the infrastructure needed for the tenant. It also has an embedded stack. So the reason for doing that is we have always faced challenges when cleaning up tenants and their associated resources, because previously we were creating resources both from Java code as well as from shell scripts. And they may have interdependency, like when we're trying to delete one resource, another resource would say, you cannot delete that because I still exist. So that's why we decided to even onboard a tenant with a CloudFormation stack. And deleting a tenant is as easy as simply deleting this stack and all of the traces of this particular tenant, like the data entered when onboarding, and also the infrastructure provision for this particular tenant will simply go away. And that's a feature that we get for free completely by using the CloudFormation stack.
Yeah, and that was that was a big challenge with the current version, or because like Bapi said, the registration service creates certain artifacts specific to a tenant, right? And then we had CloudFormation do some aspects of it. And when you, I mean, if you think of a SaaS application, right? So you may have tenants that are dropping off or moving to a different tier, right? And oftentimes you may want to just delete the tenant specific resources. We found that a little bit difficult with the current version. So that's why, for tenant onboarding, we still have a registration service, which is a Spring Boot Java microservice that receives a request. We do some basic sort of validation of the tenant request, and then we kick off a code build process that Bapi was showing, where code build takes care of all that, and then it creates a CDK, a CloudFormation stack. And when you want to delete a tenant for whatever reason, all you have to do is just go delete the stack, and all the tenant's resources would be zapped, or it would be cleaned up. So that's a big improvement from what we have today.
Yeah, I think that's a really great improvement to actually mention and give a shout out to, because we often talk about onboarding. That's very common. We talk about how to onboard new tenants, but I'm not sure what the opposite is. Is it offboarding or
yeah. Yeah.
Offboarding is perhaps something that we don't talk as much about. So having a clean process of doing that, I think that's super important.
Exactly. Yeah. Just to show another thing, we also have actually when we run the npm deploy, we also get not only tenant onboarding, we also have a tenant deletion project as well. So basically what it does is it keeps a track of the tenant specific stack, and the only parameter I need to pass when running this project is the tenant ID, and it will know which stack to delete. So there's no tying up from the code to this project yet, but this is just left as an exercise if you want to give the feature of tenant deletion or tenant offboarding, if I must say that.
Very cool. All right, so now we have onboarded that new tenant. And
Yes,
we saw
I
that
believe
it was
we have.
completed.
I will check my email. Yes, I have received the confirmation email that the new tenant onboarding is completed. I will simply copy the link and we'll try to open here. So this is the link that I received in my email. And here you go. This is the new tenant. This tenant is not logged in. Again, this behavior is exactly the same as the previous version. So if I click login, it will ask me to sign in. If I remember my email address, actually that's also sent to my email. I'll just copy it over. So my email address was plus t@gmail.com. and the password that I received in my email, I just pasted. Because I'm logging in for the first time, I must reset my password to a new one. That's also, again, a feature that we have added in Cognito. Actually, we're using the Cognito feature. And yes, so once the password change is successful, I am actually logged in now as a tenant. And this is my email address. And I am using the Twitch TV tenant. If I go to the product, there is absolutely nothing listed here. If I go to the orders, there's nothing here. Yeah, so that's basically a new tenant onboarded in less than 5 minutes, I believe.
Yeah. And if you think of the use case, right? So the SaaS provider, or at least the use case that we picked is an e-commerce. So let's say they're an e-commerce provider, and you can create storefronts with that e-commerce provider. And this tenant, I don't know, they wanted to create some kind of a streaming application, but you can think of a tenant that wants to sell something as well, right? Sell shoes or flowers or whatnot, or coffee, right? All they have to do is just sign up, and then they would create they would receive their own space with the SaaS provider, and it happened within minutes. We have onboarded an entire tenant and their resources, and they have a link that they can log on, and that's exactly where Bapi is.
So another enhancement you mentioned when we looked at that slide was the update process, how to make updates to this new solution. Yes. Should we maybe dive into that now?
Yes, I will quickly explain the update process. This is almost similar in every case. So I am apologies. I will again go into a presentation view. That's just easier to explain the update process. So in order to update anything, let's say a given service, maybe a tenant specific service, we have our EKS cluster on the right hand side, and the services are deployed for every tenant. Example being tenant 1, tenant 2, tenant 3, and the services that we have at the moment are product and order services. Let's just assume that we are about to update the product services. So the workflow might look like a developer comes in, pushes the Git pushes the changes that are made into the code commit repository of the product service only, not the entire thing, because the product service has its dedicated code repository now. So once that is done, it triggers a code build event. So code build basically takes in the latest snapshot of the code that is pushed by the developer. It builds the application, runs the test, and creates a Docker image, and it pushes the new image into Amazon Elastic Container Registry. And in addition to that, it also uses kubectl to let all of the tenant namespaces know, hey, there is a new version of the product service available. Please fetch that from the container registry. And that's how we maintain the latest version deployed to all of the tenant namespaces as soon as the change is made. This update process looks very similar for the common services as well, but instead of deploying to all of the tenant namespaces, we simply deploy to the default namespace that is hard-coded for the shared services. Because if you remember, we were just saying that all of the shared services are deployed into the default namespace by convention. And for the static sites, the workflow is very similar. We make changes to the repository for the static sites. And again, instead of triggering a code build, it would trigger a code pipeline in different stages. So stages being build the Angular site. By the way, the static sites are using AngularJS. So we build the static sites, and then we update the S3 with the newly built version of the static sites. And then we also invalidate the CloudFront cache so that the next request that is coming into the CloudFront distribution always fetches the new version from the S3. That's the workflow looks like for the static site deployment. But conceptually, they are very similar.
And we are quickly approaching top of the hour, I see now. So
Yeah.
maybe you showed a bit about CubeCost. Is there anything additionally you want to show there, Bapi, as well?
Yes. So as I was showing the CubeCost, if we click on the link to the CubeCost, it actually jumps to the CubeCost dashboard. As we can create multiple reports and stuff. But we have also added a nice nifty feature here. So in, like along with displaying the tenant specific usages, if we just click on any of the tenant name, let's say for example tenant 2, I just click on it, it actually takes me to a predefined report for this particular tenant. Although it says the tenant 2 namespace, but if you think about it, we have namespaces per tenant. So this is actually giving a report per tenant in your system for the EKS cluster. So one of the hardest thing and one of the very common question we always get from the customers is, if I'm using an EKS cluster and sharing it with multiple tenants, how do I know which part of the cost to assign to a particular tenant? Because it's all shared resource. So CubeCost is giving me that exact view that I needed to see. Okay, so total cost is $10.31 for this particular tenant. Among them, CPU usage is this much, RAM usage is this much, and the shared cost attribution for the shared services is this much. And we also get some other insights like what's the efficiency for each of the services that are deployed into that namespace. And if we tune our services and right size our pods and containers, how much we could be saving potentially. These are very, very helpful insight to have, I believe.
Yeah, and in addition to this, CubeCost can also bring in out of cluster costs, right? For example, what you're looking at is a view of the EKS cluster, and there is a tenant two namespace, right? So CubeCost can surface the EKS cluster or the Kubernetes cluster cost, but you could have RDS, for example, which is out of the cluster, right? So CubeCost has a way to integrate with the AWS, the usage reports, the cost usage reports, or the curve reports, and it can provide a consolidated sort of a view of in cluster and out of cluster cost as well. For example, if you're having RDS or something in a different service, it's able to integrate that as well.
And the next step then, I guess, based on this and the data you get here, would be to create that billing service. We had an episode, a couple of months ago, I guess now, with our friend Keith, where we looked at integrating billing with the help of Stripe. So I would suppose that would be a next step to be able to use this data in a meaningful way as well.
Absolutely.
Well, that's awesome. So with that, then I think it's time to wrap up. I think we could probably continue for an hour more, but sorry.
Maybe there was just one thing, because there was a viewer that asked about the isolation from a database standpoint. So there are other enhancements that we have done which we haven't shown. So maybe we can talk about the service account that we created, Bobby.
Yes, right.
Service account per namespace, and we associate an IAM role and an IAM policy, which means you can define a certain set of permissions at a tenant level and associate that to a namespace. We have some flavor of it in the current version, but there are some improvements as well in the new version. So maybe, I don't know if you want to just show that code.
Yeah, sure, I can. But I think it would definitely put us above the 1 hour mark. So yes. Okay. So what I'll say is, yes, Ranjit was explaining it very nicely, that we have created service account per tenant namespace, and each service account only has access to the resources that the tenant is supposed to have access to. For example, if it is a siloed DynamoDB table, the tenant only has access to their own table. But if it's a shared table, like for the products information, the policies are defined such a way that only if the leading key value is the tenant ID, the same concept is coming from the previous version, tenant can access those rows in the DynamoDB record.
So even if it's
it is there as yes.
Yeah, even if it's you're using a shared table, we have an IAM policy that looks at the leading key with a tenant ID. So only that particular tenant would be able to access their specific records and not a different tenant's records, right? So we have those models as part of the solution.
So we have a couple of more minutes. So I just want to add on a question as well, something you touched briefly on initially with API gateway and throttling, request throttling using API gateway. Can you just mention a bit more about that, how that could be used?
Yeah. So Kubernetes provides some native ways to throttle tenant requests, right? So for example, at the namespace level, you can use constructs like limit ranges or resource quotas that lets you define a certain number of amount of CPU or a certain amount of memory at the namespace level. So it's a Kubernetes construct, right? So that you can use to throttle requests. But oftentimes there are a lot of customers that want a more managed kind of a solution. So an API gateway is a great way to, a great solution there, which lets you manage your APIs in one place, but you can also throttle requests using something called a usage plan, right? So what you can do is you can create a usage plan with an API gateway for each for example, you don't have to create it for each tenant. You can maybe have, usage plan per tier. For example, you can have a basic tier usage plan or a premium tier usage plan. And then there is a concept called an API key, right? So you would create an API key and associate that to a usage plan and provide that API key for each tenant or assign that API key for each tenant, which means, if you have defined like rate limits or quotas for that usage plan, you could have like burst rates. All those are parameters or things that you could set in a usage plan. Every tenant that gets an API key gets their own allocation of those quotas, right? So which means you're able to say that, okay, I have a basic tier tenant, I've created an API key for them. There is a dedicated number of requests, or there's a specific number of requests that they can send within a defined duration, and they cannot go beyond that, right? So this means you almost protect your EKS cluster, from additional requests, right? So API gateway sort of manages all the throttling and peering aspects, and it doesn't even let the request come into the EKS cluster. So it's a good way to manage your APIs, but also establish tiering and throttling. And also you can use Lambda authorizers with the API gateway to authenticate request at the edge before even the request reaches your cluster. So those are some of the advantages.
No, that's great. We didn't even get a chance to talk about cluster autoscaler support, but we are running out of time. So maybe we need a V next version of this show as well to talk about. So to talk about more of the enhancements. I want to thank Ranjit and Bapi very much for joining today on this episode where we talked about enhancements to the EKS reference architecture SaaS solution. Bapi, I know it's approaching midnight for you. Great that you joined us, Ranjit. It's still early morning for you. Yes. And well, for me, it's time to end my day, I guess. Thanks again. Thanks to all the viewers. And I hope to see you again in 2 weeks. Bye-bye.
Bye, everyone.
Thank you.